In this video, I will be talking about Newton's second law of motion. The Newton's second law of motion, if you look at the acceleration produced in an object, then it is directly proportional to the net applied force and inversely proportional to the mass. What does that mean? That means, let me write down mathematically, A is the acceleration here. Acceleration is a vector quantity. Then this is directly proportional to the applied force. That means the more the force is, the greater the acceleration is. The summation here means it is the net external force. And it is inversely proportional to the mass. That means more the mass is, there will be a smaller acceleration produced. Okay, so this F stands for, the summation F stands for the net or the sum of all external forces. And M is the mass. From this equation, what we can write down is the net force, the F, is equal to mass times acceleration. And here, force is a vector quantity. That means the force and acceleration are always in the same direction. The force and acceleration are always in the same direction. Force and because the mass cannot be negative, so the force and acceleration are always in the same direction. I can also write down in terms of components as this force, this is the net force. So if I can write down in terms of components, the force can be in any direction. It can be in x direction, it can be in y direction, and it can also be in g direction. So the total force produced along the x-axis is now equal to the mass times acceleration in the x direction. The same way, the total force along y direction is equal to the mass times acceleration along the y direction. And the total force along the g direction is equal to mass times acceleration produced along g direction. The Newton's second law of motion can also be expressed in terms of the linear momentum. Let me write down here in terms of momentum. In terms of momentum, the force, again the total force acting on an object is equal to the rate of change of momentum. The way I can write down is rate of change of momentum, where P is equal to the mass times velocity, is the linear momentum. This is the linear momentum. Okay, and we know that now let me simplify this equation further. And again, the summation F stands for the total force acting on an object. So this one can be This can be written as the d over dt, as p is mass times the velocity. I can write down as a mass times velocity. Mass is a constant quantity, so I can take this one out and it will be dv over dt. This quantity dv over dt is the instantaneous acceleration produced in a system or in an object. So this one will be equal to the mass times acceleration, which is the same equation we just talked about here. So the force is again equal to mass times acceleration, and here I am putting the vector notation as well, because the force and acceleration are vector quantity. Okay, and always remember this F, this is the net external force. Net external force. Okay, that is the vector addition of all the forces acting on an object. So this is all about the Newton's second law of motion, and in the next video I will also talk about the examples of